Well, today we're going to study a topic called as SMPS. So what does SMPS mean? SMPS basically means switch mode power supply. A switch mode power supply is an electronic circuit which is used to converts the power. Basically, it converts the power using switching devices that are turned on and off. Basically, best example of a switching device is a diode that are turned on and off at high frequencies. This term is important. High frequencies. Very high frequencies are used to turn these devices on and off at a continuous rate. And storage components such as the inductor, the capacitor, the best example of a storage component, to supply power when the switching devices are not in conduction state. Okay, so this is used to supply power when the devices are not in conduction state. So let us take an example. This is a field. Okay, these are crops grown in the field. Okay, these are crops grown in the field. This is the canal which is used to supply water supply is done through this canal, and there is a river flowing here. So this river is used to supply water to these plants. Okay, so actually this water supply, if directly connected from the river, that is the source, to the field, if this is directly connected, this would actually damage the crops due to overwatering. So in order to control this flow of water, a device is used here that is called a capacitor. A device known as the capacitor is used. So basically we use a tank to store the water. Okay, so there is an outlet made between the track that directly goes to a tank which has a capacity to store a particular amount of water into it. So when the water flows here, this area is blocked in here, so that the water does not go here. The capacitor actually gets filled up. Okay, the tank actually gets filled up with the water, that the quantity of water is equal to the amount of water required by this crops. The amount of water required by the crops is equal to the amount or the capacity of the capacitor. So once the capacitor or the tank gets completely filled up as per the requirement of the field, as per the requirement of the crops, this water is then supplied to the field, and this area is blocked. The water is then supplied to the field as per the requirement of the crops. So this is the basic concept of a capacitor, of a storage tank that is used into fields. So relating this concept with our capacitor concept, so the tank can be replaced by a capacitor, the river or the source can be replaced by current flow, the field can be replaced by your circuit that consists of different components, power required, current components, and the controlling flow that is done by the resistor. So this is how an RC circuit actually works. Now let's see how this RC circuit, just we have studied, can be used in SMPS, which is called the switch mode power supply. So what does an SMPS basically mean? S stands for switch mode power supply. So SMPS stands for switch mode power supply. Basically SMPS is a power device which is used, or device or a power supply, basically known as a power supply, which is used to give out different voltage levels. Different voltage levels are given by the output, and these voltage levels are basically DC voltages, basically DC voltages. So the basic concept behind SMPS can be explained into just a short term as an AC input coming from the mains is passed through an SMPS, switch mode power supply, which gives a DC output, that is direct current, which can be used to power devices operated on DC supply. Now let's consider the difference between AC and DC. So there should be certain difference between AC and DC. That's why we are converting our supply power from AC to DC. AC basically means alternating current, and DC means direct current. So alternating current is the current which varies with time, and direct current is the current which remains constant with time. Alternating current is the current which varies with time, and direct current, this is not an alternating current. This can be treated as a direct current, but when the current varies with time, changing its phase, is called as an alternating current. And a direct current, the current which does not change its phase and remain constant throughout the time is called as a direct current. Understanding alternating and direct current can be done through a simple circuit. Okay, let's consider a diode here, a resistor connected here. This is a DC supply. This is a DC, or I'll call it as a 4 volt DC. This is a 3 ohm resistor. Consider this as a diode D1. Okay. So direct current basically means the current, the conventional flow of current in the case of DC is only in one direction, either the clockwise direction or the anti-clockwise direction, depending upon how have you placed the source. So this is how the current flows into circuit. But considering an AC circuit, considering an AC supply, this is how an AC supply is represented. AC supply with some frequency into it. I'll connect a device in here. Okay, AC device. Let's connect a simple load in here. Load basically means any device that you connect to the AC supply. So AC supply is represented like this, a positive wave and a negative wave. Okay, So this is a positive wave, this is a negative wave. When the positive wave travels in the circuit, it travels in, considering this is the positive wave direction. So consider this as the clockwise direction. This is a clockwise direction of the flow of AC supply through the load. When the negative supply comes, the negative supply basically flows in the reverse direction. In the reverse direction, that is anti-clockwise. So this is the for positive. This is basically for positive and this is basically for negative supply. Okay. So negative supply flows into reverse direction. This is how we generate this wave. Supply is flown like this through the load, we get a positive half cycle. When the supply reverses its direction, we get a negative half cycle. This process continues, forming a series of positive and negative cycles, forming an AC signal that is called an alternating signal, that is varying with respect to time, either changing its phase. Coming back to SMPS. So the SMPS name, basically SMPS is used to convert AC to DC. We have just understood how AC and DC are different from each other. So now, so the name indicates switch mode power supply that can supply power with different voltage ratings. Voltage rating basically means you can supply 5 volt, you can supply 10 volt, you can supply 15 volt, you can supply 50 volt, depending upon the capacity of the SMPS, depending upon the rating of the SMPS. The rating of the SMPS decides which magnitude of supply you have to give as the output. Input basically remains an AC supply, which can be 100 volt, 110 volt AC, 230 volt AC coming from the mains given to SMPS, and it gives varied outputs, that is 5 volt, 10 volt, 15 volt, 50 volt, depending upon the output, depending upon the device connected, the requirement of the device, depending upon the requirement of the device. Okay, device requirement. So this is the basic structure of a SMPS. Now let's make the flow of operation, as in how the SMPS actually works. First is your mains input. First comes your mains input, that is given to a input rectifier. We'll come to each and every block in detail later on, but first we'll understand the flow. Input rectifier and filter, then it is given to a inverter, after the inverter basically is called the chopper. It goes to the output transformer. The output of this transformer is given to another output rectifier and again a filter design, and here you get the DC output. Here you finally get the DC output. So mains input, either the 230 volt supply, is given to an input rectifier and filter. The output of the input rectifier and filter is given to an inverter, either chopper. This chopper output is then given to the output transformer. The transformer output goes to another rectifier and a filter connected at the output, and that rectifier and filter actually gives a DC output. Now let's consider the basic logic behind SMPS. Logic behind SMPS. So what does SMPS actually do? It is used to obtain a regulated DC from unregulated supply. What does regulated mean? Regulated means constant DC, constant DC output. Unregulated basically means there is presence of some AC component into it. So basic logic behind an SMPS is to regulate the output, to regulate the AC into DC. This is how a simple SMPS looks like. This component shown here is an exhaust fan. This basically is used to throw out excessive heat generated inside the circuit, as a lot of power devices are used into it. So this is basically used to throw out heat. Next is this case. Basically this case is just a protection of the circuitry shown here. This is just a protection. This is the fan outlet. The fan is connected here like this. This is your supply, wherein you give the supply. There are two sections in here. One is to give supply and the other is to get the output, either the DC output. So input given to this supply is 220 volt AC input, and the output that actually depends on the requirement. So this is the basic circuitry that is present inside an SMPS. A series of wires, each wire represented here gives out a different output voltage depending upon the color shown here. Actually each color of the wire gives out different voltage. So the voltage of these wires is shown here. So V voltage, that's the input voltage, that's the AC input voltage, which is shown as 115 volt or 230 volt. Current input as 8 ampere and 4 ampere, and frequency that is 50 to 60 hertz. The DC output shown here is the output given by the SMPS. So the colors, that is orange, yellow, blue, green, red, purple and so on, are actually the different voltage levels that we get, the different voltage magnitudes that we get as the output from the SMPS. So each color wire represents a different output voltage level. Coming to the circuitry, so here you can see this two bar like structures which are called the heat sink. What actually does a heat sink do is, the power device is connected into this circuit emits a lot of heat when they are into use. As this is a power supply, it also consumes a lot of power and generates or emits that power in the form of heat. These are used to absorb that heat and radiate into the atmosphere, allowing the device to function properly and to maintain its function. That heat generated by these heat sinks are exhausted or removed by a device, that is the fan. This fan actually is again powered by the supply given to this, and this fan removes a lot of heat that is generated into the circuit. The heat sink emits these heat in the form of radiations or waves. That waves are thrown out by this fan. So let's start. Exploring each and every component present into this. As it's visible here, as you can see, this is the heat sink. These are two big capacitors used to store the charge. This here in the middle, this is a transformer, either a step down transformer that converts voltage level, high voltage level to low voltage level. These are few capacitors connected in order to maintain the charge or maintain the flow of current into the circuit. Few resistors connected in here, a series of resistors connected here in order to restrict the flow of current or to allow the flow of current in a smooth manner. These are diodes connected here. These diodes are used to regulate the supply, either connected in all these. Actually, diodes are connected into different configurations, forward and reverse. This diode is connected in forward, reverse, forward and forward biased. Okay, then we have a transistor, few transistors connected here. Basically, this heat sink is supported by three transistors. This heat sink is supported by three transistors shown here as one, the other one here, and the last one is here. These are three transistors. Basically, transistors emit a lot of heat, so a heat sink are used. Same here, these three transistors are connected. That's all about the circuitry present. This is, I think that's a filament wire or a fuse wire. And what else? There's an IC, the IC KA700BD and the IC C339C. These ICs are basically used for controlling the voltage. This was all about the construction of switch mode power supply. Now let's understand how does a switch mode power supply work. Basically, we know that switch mode power supply converts AC to DC, but SMPS can also convert DC back to AC as well. Okay, so this conversion from AC to DC is done in the following way. Okay, let's first consider AC to DC conversion. So considering this as an AC wave, the basic sinusoidal wave, considering this as an AC wave varying with respect to time, and this is your voltage. Okay, so this AC wave, when given to the SMPS, first of all, this wave is converted into a rectified signal, basically a half wave rectified signal. What does a half wave rectified signal look like is, the positive part of the half wave signal reflects as it is, but the negative part is clipped off. The positive part again remains as it is, and the negative part is clipped off. This is how a half wave rectified signal looks like. This signal can also be taken or considered as a simple DC signal, but this signal is passed through a full wave rectifier. So So this signal is a full wave rectified signal, this is a half wave rectified signal, and this is the AC input. The conversion from AC to DC is required in order to allow the SMPS to work properly. So as our SMPS requires an AC input, hence the conversion of AC to DC is required. Actually, SMPS can work on AC as well as DC power supply. Now, as SMPS, considering SMPS to be a DC power supply, or we need a DC power supply at the output. So consider that we need a particular magnitude of voltage at the output. So how does the conversion take place? So first of all, the rectifier produces an unregulated DC voltage. What does an unregulated DC voltage look like? This unregulated DC voltage called as the pulsating DC. DC voltage is present in the form of pulses. So pulsating DC cannot be directly taken as the output because it creates unstable power supply. Basically, this pulsating DC is not a good supply to be given to any component. This is because the supply actually oscillates between two levels. Considering this to be a 5 volt, this oscillates between two levels, 0 5 volt, then 0 then 5, 0 then 5, 0 5 0. Oscillation creates an instability in the component. Basically, the component will not function as the component should function. So this signal cannot be directly given to a component. So in order to give a supply voltage to a component, this signal should be converted into a simple straight DC. Simple straight DC basically means a constant supply. This is a variable supply. This is a variable DC. You have to convert this variable DC into a constant DC supply. In order to convert this pulsating DC into a regulated DC output, this signal is passed through a capacitor. So what does a capacitor do? This will be explained now. What is the basic function of a capacitor? Basically, a capacitor is a storage tank. As we have discussed earlier, capacitor is a storage tank which stores the amount of current or the amount of charges into it and releases those charges when required. So a concept in the capacitor that is called as the RC time constant. RC time constant comes into picture. So what does the RC time constant actually mean? So let us consider this, a pulsating supply which we got from the full wave rectifier. Now we have to convert this pulsating supply into a constant DC. Okay, so how can we do it? Pass this through a series of capacitors. So after, the basic task of capacitor is to create charging and discharging. So basically during the upper threshold, when the supply reaches upper threshold, the capacitor will start charging. So once the capacitor is charged to its maximum level, as in going down, replicating the wave, it will start discharging in this fashion. It will start discharging. Again, when the positive part comes here, it again starts charging and then discharging, charging and then discharging. So this is how the output of the capacitor looks like: a charge and discharge wave, a charge wave and a discharge wave. So these waves basically categorized into charging period and a discharging period. Two periods, a charging period and a discharging period. So this phase change, this change of state of charge, discharging to charging period, occurs when the charge when there is a shift of phase, when there is a change of phase. As the phase changes, this again starts charging, again discharge, charging, discharging. So the output of the capacitor looks something like this. So this is the charging period, this is the discharging, slow discharging, again charging, slow discharging. So this period is termed as the time period of charging and discharging considered together. So the time period charging or discharging is denoted by the letter tau. This is called as the tau, that is the charging, that is called the RC time constant, the charging and discharging time constant, that is tau is written as R into C, RC time constant. So now how can this concept be used to produce a DC supply? So the discharging time of a capacitor can be, the discharging of time of a capacitor can be varied in such a way that it produces a constant output. It produces a constant output, and constant output basically means DC, direct current. So changing or altering the capacitors or altering variable capacitors can produce a DC output. This is how a DC output is generated. Now as we have generated a DC output through the capacitor by controlling the RC time constant of the capacitor, so the DC voltages can have magnitudes like 5 volt, 3 volt, 7 volt, any magnitude. So in order to get the specified magnitude, a voltage shifter circuit is used. Basically what does a voltage shifter or a voltage voltage shifter means a voltage converter. Basically it converts 3 volt to 5 volt, that is either stepping up, or 3 volt to 2 volt, stepping down the voltage. So these level of the voltage is converted by voltage converter. Before this conversion, there is a single stage called as the inverter stage. That inverter stage converts DC whether directly or indirectly into AC by a power oscillator, producing a constant oscillations of the output with a very small output transformer of 10 to 100 kilohertz. So basically there are three types of voltage converters present in SMPS. Wait a second. What is a voltage converter? So for a DC output, AC input is rectified. In order to, as we have seen, to get a DC output, the AC input is rectified to get a DC output, and that DC output is shifted by a shifter circuit that actually can be used to produce different magnitudes of DC level. For output voltages about 10 volt, ordinary silicon diodes are used. For output voltages above 10 volt. For lower voltages, Schottky diodes are used as rectifiers with fast recovery time. For even lower voltages, MOSFETs are used as a synchronous rectifier. The rectified output is smoothened by a filter with inductor and capacitor. To smoothen the output or to get a perfect output without any AC component into it, capacitors and inductors are used. Now voltage converter is categorized into three types, that is boost converter, buck converter, and last one is the buck boost converter. Voltage converter is categorized into boost converter, buck converter, and buck boost converter. So let us see the individual circuit diagram for the following. First of all, the boost converter. What does a boost converter do? It has an inductor followed by a diode with a switch connected in the middle, a load connected at the end, and a supply. So this is the basic structure of a boost converter. This converter, basically this switching actions. This switch is continuously on and off, producing a pulsating output, and that is rectified and passed through a filter to produce a DC output. This switch is continuously oscillated, continuously taken into two states, that is on and off, switched into two states. Next, this is the boost converter. Next comes the buck converter. This is similar to the boost converter, but here the switch has just replaced its position, and a new device, that is a new component, that is a capacitor, is added in order to regulate the charges, regulate the flow of current, followed by a load. So this again, this switch is oscillated or switched between two states on and off. Last comes the buck boost converter. Buck boost converter, that is the combination of buck and boost converter, that is shown here. This is a switch S3, considering S3. This is a diode D3 connected here with a load resistor, an inductor coil with a supply voltage. So this is the basic combination of a buck and boost converter. Now let's see the features of different types of converters. So considering type of the converter, the power range of the converter, the relative cost of the converter, the energy storage, and features. So these are different types of converters. First of all is the buck converter, which has a typical power range of 0 to 1000 watt, a relative cost of 1, an energy storage of single inductor, and features having continuous current at the output. Second is the boost converter, which has a power rating of 0 to 5000 watt, 1.1 relative cost, an energy storage of single inductor, and an energy is continuous in the output. Last but not the least is the buck boost converter, which has a typical power output of 0 to 150 watt, relative cost of 1, a single converter, single at the output, and current is discontinuous at both input and the output. This was the complete overview of how an SMPS works and what do you mean by a switch mode power supply. Thank you.